In this video, what we're going to be doing today is we're going to be looking at intermolecular forces and trying to identify using the structures below as to what intermolecular forces are present, and then answering the basic questions that you see in following. So what first thing I'm going to do is I'm going to go through and let's just identify the intermolecular forces that are present. So letter A, in molecule A, I see that I've got an OH group that's going to present hydrogen bonding. So we're going to have hydrogen bonding, dipole, and then London dispersion for A. For letter B, it's a polar molecule. I can see that just because there's a differences in the elements. It creates a polar compound. If there's symmetry, then yeah, it would be nonpolar. But this one is asymmetrical, meaning that it's going to be polar. There are no hydrogen bonds present because you don't have the three oxygen, nitrogen, and fluorine present. So this is going to be dipole, and London dispersion. For letter C, well, this is an ionic compound because you have the metal bonded to the non-metal. So the sodium is metal. Didn't know that already. Now you do, right? But letter D is, again, you've got your carbon, 3 hydrogens, but you have an alcohol group as well. So letter D is going to be H bond, dipole, and London dispersion. Letter E, silicon with 4 bromines, that's symmetrical, London dispersion. Same thing with F, London dispersion. Now G is dipole, and London dispersion. The lone pair gives you that asymmetry there. Letter H is London dispersion. I has metal, therefore it's going to be ionic. And then last but not least, J is going to be dipole, and London dispersion. So letter A says which molecules experience dispersion forces as the primary intermolecular force. Well, we can see E, F, and H. All three have only London dispersion. Considering the compounds you listed A, part A, which one has the highest boiling point? Molar mass is key here, so figure out which one has the molar mass that's greatest. Alright, so what we can see here is the silicon. So letter F is not going to be, so F is out. So we have to look between E and H. Well, E has the silicon versus carbon and H, so E will be our answer for that. Again, you can go through and figure out the molar mass of E, H, and F. Which one has the highest molar mass yields the highest boiling point. Stronger dispersion forces. So which molecules experience dipole forces but not hydrogen bonding? Well, that's going to be B, G, J. Let's make sure we check ourselves here. So G, B, and J. Perfect. Which of the above compounds contain ionic bonds? C and I. Which molecules experience hydrogen bonding as their primary force? A and D. Even though the structure of A, the carbon chain, is longer, it's still not long enough yet to make the dispersion forces dominant over the H bonding. So now the last question says F. Letter F says, consider the compounds you list in part E, which one has the highest vapor pressure? So that's going to go back to understanding which one's going to have weaker interactions and ultimately which one's going to be able to evaporate quickest. Size is going to play a critical role here. So letter A has a pretty large surface area, so it's going to be a little bit more challenging to break it apart in comparison to D. So in that case, D is going to have the highest vapor pressure. So in this particular problem, you have to establish the intermolecular forces first before we can answer the individual questions. But then when you get into the questions, then you can kind of go back and look at how the structures and those intermolecular forces tie into the physical properties you might observe, and so on and so forth. So intermolecular forces are important. It's something that you need to make sure you understand, and especially knowing how to determine which compounds have what intermolecular forces. So keep in mind that there are 4 intermolecular forces of interaction. There's ion dipole, there's dipole-dipole, London dispersion, and hydrogen bonding. Hydrogen bonding being very specific dipole-dipole, where you have nitrogen, oxygen, or fluorine covalently bonded to the hydrogen. Ion dipole is where you're going to have, just like in C and I, those would have ion dipole interactions because they have a metal. You put that in the water, it dissociates, and then you have those interactions within the water molecules themselves. And remember that water has dipole-dipole interactions. So, well, I hope this helped you guys in understanding a little bit more details and how to go about using the structures and figuring out intermolecular forces and answering specific questions based off of that. So, thanks for watching.